Welcome. How do you define cloud-native networking? For you, is that a collection of projects? Is that particular technologies, container networking, virtual networking, software-defined networking, intent-based networking, service meshing? Well, these are concerns that we try to address and help uplift and clarify inside of the CNCF SIG network. We work closely with all of the network-related projects that are within the CNCF. SIG network was formed not too long ago. It was about a little over a KubeCon ago, if you will. We were formed with a particular mission, and that is to help people do cloud-native networking and do it well. We do that by trying to help projects collaborate and interrelate to one another by seeking to clarify and inform in general. We aim to assist our existing projects and attract new ones, provide people a venue for vendor-neutral discussion and kind of advancing of thought in the space, of capabilities in the space. There are three of us that are chairs of the CNCF SIG network, Matt Klein of Lyft, I'm Lee Calcote of Layer5, and Ken Owens of MasterCard. The last time that we addressed you was KubeCon San Diego, KubeCon North America 2019. At the time, we represented CNI, CoreDNS, Envoy, gRPC, Linkerd, NATS, Network Service Mesh, which was a fairly recent addition at the time. And since then, we've been fortunate enough to bring in 5 more projects, 4 of which are at a sandbox level and 1 of which is at an incubation level. So BFE, CNI Genie, Contour is at an incubation level, Kuma, and Service Mesh Interface. So we've been busy. There are more projects on the horizon, including some that are under active review. So Ambassador, Chaos Mesh, Meshery, and the Service Mesh Performance Specification. Now, outside of projects that call the SIG network their homeroom, if you will, the SIG network also facilitates working groups. The UDPA working group, or the Universal Data Plane API working group, the Service Mesh working group. We also are, actively considering trying to help inform in general, and might do so through some white papers. There's one that's been written and is referred to as the Cloud Native Networking Principles. These are being proposed for incorporation into SIG network. There are also any number of patterns and reference architectures that are likely to come out of some work that's being done inside of the Service Mesh working group. The SIG network also entertains presentations in general that are relevant to the space, and have received 1 or 2 of those. There was an interesting one given not too long ago that you see linked here. You'll find those and each of these links inside of github.com/CNCF/SIG network. So there's a lot that gets done inside of this group, and more that we're hoping to get done. And actually, some of what we've got planned for between now and next KubeCon, we'd really like your input on. Not just your input, but your participation. I'd like for you to bring up topics and meaningfully impact our focus. The calls that we have are twice a month. All are welcome. Whether you're your organization or you specifically are a member of the CNCF, but just so long as you've got interest in the space, please join, read through the meeting minutes that we have public right now, and determine whether or not the topics that we have currently are of interest. If they're not, please suggest new ones. So I want to take the rest of the time that we have together to review some of the initiatives. We have any number of those 5 new projects, which are all unto their own exciting. We also have the Service Mesh Working Group that is advancing a few different initiatives that I'd like to highlight and introduce to you if you're unfamiliar with these. Now, some of these initiatives that we have some common goals. Part of seeking to clarify and inform in general means that we will put to use the CNCF labs, the CNCF cluster. It's generally available to projects, to those that are looking to do generally like at-scale testing, to run on some hardware and quite a few pieces of hardware that aren't always available to these open source projects. And so performance testing is commonly done here, or just things about resiliency and HA. Anyway, the part of the common goals across the initiatives that I'm about to describe are that we would publish some results from these studies and do so in an ongoing fashion. Now, to provide a little bit of more context for the initiatives that are going forth, is to say that we live in a multi-mesh world. And so the initiatives, again, that we're talking about here are executed in the Service Mesh Working Group. And so hence a very Service Mesh-centric focus. These abstractions have arisen because it is a multi-mesh world that we live in today, and that we see users and organizations deploying a variety of meshes for similar but different use cases. You have different tools for different jobs, and so different service meshes for different jobs. Because of that, we see some abstractions, some APIs that work across service meshes and help them either interoperate or just help abstract away the particulars of a given mesh. The first one that we'll talk about is Service Mesh Interface, or SMI. It's a standard interface for interacting with or adopting and operating any given service mesh that implements the spec. Another specification that's coming forth is the Service Mesh Performance Specification, or SMPS. It's a standard for describing and capturing the performance of a service mesh. The next one that has been in the ecosystem for a little while, and we're just starting to address inside the Service Mesh Working Group, is Hamlet, or the Multi-Vendor Service Mesh Interoperation. This is, they're all complementary, but this is a set of APIs that enable service catalog federation or federation of services from one service mesh, maybe to another. And maybe those are of the same type, just two different deployments. Maybe those are heterogeneous, two different types of service meshes. So much going on by the way of specifications and standard APIs. Of the first specification, SMI, as any service mesh implements against that spec, qualification of whether or not that project has done so in accordance with the specification needs to be performed. So to validate that implementation conforms to SMI specs. There are about 4 SMI specs today. And so of the initiatives that we're speaking about, this first one, it's being done in coordination with Community Bridge, and which is a Linux Foundation project that does a few different things, but one of them helps out CNCF projects like SMI. And so the purpose of, there's a tool being built, and the purpose of it is to provide an easy to use tool that allows you to repeatably verify whether or not a service mesh is in compliance with SMI specifications. And so this tool is intended to be used by not only SMI as a project, but also by each of the individual service meshes that are implementing SMI, so that they can, in an ongoing way, validate their conformance. It's also available to end users or to those that are adopting service meshes for them to perform similar validations. The tool does generate a report and runs it asserts any number of tests, and that report then is yet to be published publicly. But as the tool gets towards its final phases, that's part of the goal. In order to validate conformance, and in order to do so, in order to do so, a service mesh needs to be deployed. A workload needs to be deployed, a sample workload onto the mesh, and then its interfaces, the SMI interfaces, need to be exercised. And so the tool performs those things. In this case, this is Meshery, the service mesh management plane, is working in conjunction with SMI and its specifications, deploying a sample app called Learn Layer5, which really works as two different things. It works as a sample app for conformance testing with SMI. It also works as a sample app in general for learning how service meshes work. So if you're interested in knowing more about that project, there's a few different links on the page. Each one will get you to that project, or you can just go to the SMI community meetings, which happen every couple weeks. This next specification is the Service Mesh Performance Specification, or SMPS. It's a vendor-neutral performance standard for measuring how well a given mesh's implementation is running, and actually answering that and capturing that, kind of describing it accurately and holistically. It's fairly challenging. There are a myriad number of variables included in ascertaining what the performance of a given mesh is. That's highly dependent upon what the environment is like that it's deployed in, how many nodes there are, how many clusters, what the size of them are, what resources they have available, what mesh you've deployed, what version of the mesh you've deployed, what workloads are running on the mesh, what the mesh is configured to do. The more that is asked of it, the more it costs to run it. Costs, kind of with quotes. This particular specification describes a standard way of capturing all of those details that we just mentioned, and also providing a standard way of reporting a statistical analysis of load that has been generated against the services running on a mesh, and the reporting of those stats. So there's a fair bit to this. It does directly do the things that we just mentioned, and is a standard way of doing that. It does then, kind of on top of this spec, facilitates a few different things. Arguably, most importantly, it facilitates end users having a common way to baseline their environment, benchmark the performance of their mesh as they've initially deployed it, as it's running in a particular setup. And then over time, as that environment changes, as their configuration of the mesh changes, as their workloads change, that they're able to use this standard format, this standard spec, to measure service mesh performance again and again. It facilitates then potentially comparing one deployment to the next, and having it facilitates also having a performance index, a unit of measure to identify how well a given service mesh is performing. So, I guess to give a further example of that, this isn't included in the spec, but is the performance index that I was just mentioning. There is one that's coming around. It's called Meshmark. It is that simple index that I was just referring to. So it's a very simple way of quickly articulating the performance of a service mesh and the value in context of the value that it's providing. If you're asking the mesh to do a lot, invoke a number of traffic management rules. If you're asking it to encrypt things, traffic east and west, well, that affects the performance of the mesh. The more that you ask it to do, the generally, and this isn't always the case, but it depends on your deployment and your environment. Generally, you would expect that you have to quote unquote pay more for that. And so Meshmark is an easy way of it's a way of providing a unit of value so that you can speak to how well a mesh is running. Maybe yours is running a Meshmark of 90. Maybe there's a similar deployment that's running a Meshmark of 85, maybe lesser. Right? The examples that I'm giving here are just random examples. The unit of scale is still to be hardened and completely defined. But the point is, maybe between these two different environments, you've got really the same service mesh, same environment in terms of nodes and their resources. Maybe you're asking one to do more than the next. And many of us that are running service meshes don't necessarily have an easy way to gauge whether or not we're deriving the value that we're paying for, that the overhead of the mesh is in fact worth the what we're getting out of it. Generally, it most certainly is that case, but it's really hard to articulate and compare and understand and reason over whether or not you've got your service mesh tuned in the right way. The next project is also being done with through the another internship program called Google Summer of Code. And this one has to do with really a recognition of the fact that many of us are running, essentially distributed systems. We're running microservices and, potentially plenty of them. And the analysis that you'll often see about understanding the performance and kind of the behavioral characteristics in terms of performance of a given set of microservices is usually done from sort of a single instance of a load balancer, a load generator, excuse me. So you might generate load against one load generator. Oftentimes a closed loop load generator might be creating a bunch of HTTP traffic pointed at a particular endpoint, pointed at a particular service. And and you can analyze the behavior of those services. You can analyze their response time, their latency, the throughput that they receive. But that's maybe missing part of the point of the fact that we're running, we collectively are running distributed systems. And so shouldn't our performance analysis also be distributed? Shouldn't we also have multiple instances of load generators hitting various endpoints of your different microservices? Micro or not, but hitting different endpoints of your services, and then doing analysis of each of those loads that were generated, how they responded, coalescing those results. So there's an ongoing project now that's working with the Nighthawk load generator of the Envoy project, and pulling that and then using its capabilities, enhancing its capabilities in context with the service mesh management plane Meshery, which already supports two other types of load generators, WRK2 and Fortio, and also supports Nighthawk now, but will support it in a distributed fashion. So an interesting project. We're expecting some novel results. So with that, I'll make another call for participation and say, these are open projects. If you find that those are of interest, those are a sampling of initiatives that are taking place in context of the Service Mesh Working Group inside of SIG Network. SIG Network itself is much bigger in scope than those four projects, those four initiatives, I should say. And part of that is the scope around all of the other member projects, which we talked about at the beginning of the call. So all kinds of things going on, all kinds of things to get involved with, and you're very much so encouraged to. If you have questions, I will be in the Q&A, likely joined with the other SIG network chairs. Please bring your questions. Please show up for a meeting and suggest a new topic. All right, we'll see you soon.